How's it going, everybody? We are continuing the project that we worked on last time. And we've built it over a few streams now. We sort of like picked it up and put it down. But why is my phone making noise? Shh, quiet. It's okay. Whoop. I meant to put it on silent and I accidentally put it on the opposite of silent. So what we're doing with this is we're making a little like to-do. So these like intro things, we can set the stage and then start listing off the things that we're actually going to do in the stream, and I can sort of stick to it. To be clear, I don't mind the questions and digressions, but to give some context for folks joining in after the stream starts, I think it'll be helpful. And then we can use it to potentially make timestamps, because I know folks have been asking about that on and off for quite some time. And it's hard to do it after the fact. At least it's a significant amount of effort that I haven't been able to put forth. So hopefully this will make that process easier. Now what we're doing today is we swapped out, and we were using a file to be like the cache, the persistent content. We set it up to where it writes out to that file. We're not doing anything at the moment with bringing it back in. We're going to pull in a new library, one that I've used before. We'll look at that in a second. And that will make that process a little bit easier. And then we're going to hopefully hook up the WebSockets to my streaming software. And that will, if we can get it all working today, that should give us timestamps. So then we will end up finishing effectively like the stream as we've checked off these to-do items with like a timestamped file that I can hopefully use to put chapters in each stream. So like in general, I think it's kind of a cool little app, but it also has a lot of little bits that I could see showing up in other apps, which serves as a good example and something fun to talk about. Hey Darth, good to see you again. So let's hop on over. I've got things opened up already. We had teased this before. We're going to pull in a library called Starfx. So there, I guess a little bit of background on why I'm pulling this in. It is in some ways like a spiritual successor to Redux Saga. So if you're in the React ecosystem, one of the earlier like global state management frameworks was called Redux. And it still exists. It still seems to be pretty highly used. And a branch off of that was a thing called Redux Saga, and they used generators, which there was benefits to that, but then there was also some downsides, and those downsides were very difficult to overcome, partly just because of the way generators are implemented and like in the language, like language type issues, but also with the way that Redux Saga was set up. So this, in some ways, is looking to hopefully solve some of those issues. And this is also built on top of a library called Refactoring. Full disclosure, I work for Frontside. They are my employer. Frontside puts out a few open source libraries, Refactoring of which is one, and it's sort of the lower level piece, and we've got a bunch of stuff like built on top of it. Refactoring is the buzzword is structured concurrency, and what that is it's sort of a different and in some ways better. Definitely, there's a little bit of opinion here, but it's a different way to handle the asynchronicity. So rather than trying to rely on async await and the promises actually going out and resolving without issues, structure concurrency is a way to control that a little bit better. So it provides you finer grained control of especially these like situations where things fail or like tear down. I've used it a lot in running like local simulation type servers where we want to stand a bunch of stuff up and tear a bunch of stuff down, potentially multiple times in the life cycle of that process. Super great for that. And actually, I guess sometimes I actually forget about it, but I wrote a library called covector, and this is what we use in Tauri to publish all of our packages. It's speaking of spiritual successors, we needed to be able to publish multiple types of assets. We were using chain sets, and chain sets didn't want to expand past its scope. So we wrote covector. Covector is built on top of Refactoring. So all of those, like when we try to publish a package or we try to push up an asset somewhere, the failure mechanisms and resolving that were much cleaner to write with Refactoring. So we are going to pull in Starfx. You might see a little bit of generators. You can think of generators like functionally equivalent to like async await, except with additional features that we're gonna hopefully pull in a little bit and use. So first thing we're gonna do, we're gonna pull in Starfx, and I think that will allow us to hook up and set up the like persistence to the file system store pretty quickly in a way that's going to be like sort of automatically or automatically maybe isn't a good word, but like it will kind of just, once we set it up, it'll handle it in the background. We don't need to think about it as much. So that I think will make our process much easier. So I guess we pull that in and start rolling with stuff. Let's close a couple of these tabs here. So there's some pretty decent examples that we could go off of. In this case, we're probably not going to be using the like there's literally a API called API, and that the intention of that is to it's sort of like in the vein of like React query, where you have a bunch of middleware and set up to where you can more easily make a query, and all that middleware handles all the little bits in between. Like you can see here, base URL and schema, etc., etc. But we're going to be all doing like internal stuff, or we're not going to be reaching out to an API. So we're going to be using mostly the API called thunks. Thunks are the functions that you can set up to like run an action. So when we do an interaction, it will run an action, which will at the base layer like be executing a thunk. API, the API is built on top of thunks. So thunk is sort of like that base level piece. Most of these examples and how you typically use this library is more focused around API. So I'm not going to actually go ahead and copy any of these. Let's just add it to our package JSON real quick here. And then, we're probably going to end up pulling out React Stately. I mean, it was fine for what we were working with, but the way it handles the way we're able to like handle the asynchronicity to then write out to a file is kind of kludgy. Which, I mean, React Stately doesn't seem like it's really intended to be a like full-scale state library, but more of a, it's sort of like built in parallel with React ARIA components. So I think we're like kind of out of the use case of React Stately making sense. So I don't feel like I guess I don't feel bad about abandoning it, because I think we're kind of out of scope at this point. So we'll probably end up removing that, but I'm going to leave it in for the moment. So we're going to add in Starfx. I think that's all we're going to need. I think that's all we're going to need at the moment. So let's do an npm install. And what we're going to do, speaking of libraries and stuff that I'm involved with and written, I'm going to pull a bunch of code from this. So if I'm not burning my free time on doing work with the Tauri ecosystem or doing videos for y'all, I'm probably spending my free time on this. So anything like non-family, I'm digression on the digression. I got a 3D printer here. This I just printed. Phone stand. I'm qualifying that as family time. I think I've printed more stuff for my my kiddos than I have for me at this point. But if I'm not doing videos or Tauri stuff, I'm working on this. If you're at all interested in personal finance and like planning for the future, especially around money, check this out. Open source thing. There's also a Discord if you want to hop in and chit chat. I've been working on this for some time, and a lot of it is, and this actually goes back further than this. I've got previous iterations that aren't represented by like this code of conduct might have updated a couple of times. I've been working on for a little bit here, and part of it is, and you can kind of see this a little bit in our streams. Part of it is what I want to do with this and what I think is valuable and beneficial. The tech to do it, at least as a single person, just wasn't there yet. I mean, it went through what is that? Knockout.js. Well, one of the original iterations was written in Knockout.js, and so it's been like reasonably functional for a while, but it just hasn't gotten to the point where like I love working with it and I love using it. But I feel like the tech is really just starting to get there now. We actually have Starfx wired up in this, and I do kind of want to wire up some sort of like peer-to-peer local first type library potentially, because Starfx is built on top of Immer.js, or that's the thing that is controlling the actual state, which is fine. It works well for many cases. In this specific case, though, that sync engine is like, it feels really important to me. So I like the DX and usability and the performance of Starfx. I just want to hopefully swap out the store for like YJS maybe. And you can kind of see that in some of the streams. We've been playing around with local first stuff for a little bit now. I think having that like peer-to-peer local sync, especially for something like this where it is very personal, and I don't think anybody should own the state other than you. I want to get it to work here. So anyways, pitch done. Check it out. Would love to see folks playing around with it, and I'm always happy to chit chat about it. Until that point, though, we are going to steal some code from it. So I've got a folder called store, and we're going to just grab some bits here. We've got a little bit in here that we're not going to actually need to do or need to use. So we'll kind of just strip it out as we go. Speaking of like persisted state, as sort of an interim thing until peer-to-peer thing gets a little bit more solved, I did wire up Supabase to this. So we'll see a bunch of Supabase stuff in here, and we're probably going to, we'll strip that out when we pull it into our project. Build your fertilizer calculator in Tauri. Interesting. So is this like determining how to mix it for specific plants? I've never heard of like a need for a fertilizer calculator. I'm curious. Was that yeah, yeah. So does like do different plants need different like mixes of fertilizer? We've always just kind of Googled something and whatever random, 40-60% thing we found, we just went with it. I've got like a nice high pressure aeroponics. Interesting. We've got I built like a I think it's like 6 foot by 3 foot by like 3 foot deep planter out of cedar. I built that like, I don't know, 4 years ago, and we grow tomatoes and basil. Speaking of we were talking about what, French food a couple streams ago. Caprese, yeah. A strawberry needs a different stuff from basil. Yeah, that makes sense. We've never had good luck with strawberries. Tomatoes, though, I feel like tomatoes and basil we don't have any trouble with. We can chuck them down and we get a whole ton of them, which is nice because like we go through a lot of fruits and veggies. Some of the other stuff like cucumbers, the yield that we get from planting a cucumber would be enough for like a week, and it just never feels worth it. So we usually there's definitely some plants that we just don't bother with, and we only buy it just because the yield is not high enough for it to be worth the effort. But some homegrown tomatoes, oof. And the basil, just having fresh basil on hand all the time is great. But it's winter now. I don't know. You can see a little bit of the light. We got snow, so it's bright outside because of all that sun reflecting off the snow. Okay. What do we got going on here? Could not resolve. Oh, yeah. Okay. So there is still some in Starfx bits from React Redux, which does actually require at least the version of React Redux that Starfx is using is built on top of 18. So we'll just do a little downgrade here. We're not actually like using anything from React 19, so I don't think it's really gonna matter that much. Maybe our soil has a lot of nitrogen. Yeah, it's like yeah, and you might actually know offhand. I was gonna get those like little alkaline strips to test our soil, but I have no idea if that's even like worthwhile or useful. We have gotten it's not like fertilizer, but the soil with like fertilizer in it, and it's like vegetable fertilizer. But I don't know. I haven't hyper focused on it enough to get any further than, I don't know, that looks good. And it doesn't seem like it really matters too much for the tomatoes. But it could very well be that we have a lot of hydrogen. And stuff. That's, stuff. I think I get you. Yeah, I don't know. It's a lot of work doing plants. It definitely is a hobby if that's something that you're interested in. My wife has gotten into succulents. We've got a bunch of succulents in the other room, and I guess a few of them right there. I'm okay with some of it, but you could definitely eat a lot of your time up if you allow it to. Okay. Speaking of a lot of time, let's pull this in, and I've spent a bunch of time on this. It would be nice to reuse some more of it. So I think I'm just gonna add a store folder. We'll say store /setup.ts, and then we'll put that in there. And we don't need anything with Supabase, so we're gonna remove all those bits. That's gonna, and you can see here we define a schema We're not going to need any of those bits. I don't care about dev tools right now. We might need to do something with this. So we're just stripping some stuff out here that we for sure won't need to use. Take out Supabase. And the auth. We don't need anything with the auth. I guess we can take this off too. Okay. This starts to. Is it worth looking at this bit? I don't think it's actually worth looking at this bit. We'll kill all this. Yeah. That limits what we're looking at a little bit here. So to come back around and explain what's happening here, we're setting up a store. This will be like Immer.js, and we can add a persister to it. And a persister is a mechanism that when you change the state or you load in the page for the first time, it will push or pull that state from wherever you've written your persister to handle. In this case, this is a local persister, as in local storage. So it has, one of the options is an allow list. You give it a list of like keys in your schema that it'll save, and it will persist those to local storage. So every time you change or load the page, it will use that as like the base. The reconciler is when you're coming back in. We're probably going to need this, and we might need to do a custom one when you're coming back in. So you're like loading content. In our case, it's going to be a file. We need to take that string that we're loading from the file and reconcile it into something that can be like pulled back into the database. So we don't need this. We're probably gonna have to make our own, including a reconciler. But that's fine because we've basically already did that. We'll leave that in there for right now, and then we'll come back to it. And what we then do is we create the store, we give it a schema or an initial state, and then we add the middleware. So the idea of like Starfx is that when you do actions, it pipes it through a bunch of functions. Middleware. Kind of in the same vein of like if you've used Express or some of the other Node.js server frameworks. And it's kind of nice because you can have each function sort of like do its own specific thing and then just go on to the next one. I don't know. I mean, technically we're going to be using it here. We're going to be using the middleware for the persister, I think, is probably the thing that's going to make sense. So then effectively what we'll do is when we do an action, so we add a task or we remove a task, after that task is, basically like saved to the local state, we can then, through this persister, write it out to the file. So in our actual like view code, like in the React code, we don't even need to think about that. We write it once, save all the stuff, and it'll do the in and out for anything with the file system API, which I think is going to be really nice. And then the other bit, which we're not going to use at the moment, but I think this is going to come in for the WebSockets. There's the idea of tasks where you can each one of these things, the store and the persister and whatnot, are tasks. So we can basically have these like persistent things running, effectively like watching events. So when an event or something happens, this task will then handle it. So we can wire up any of those like asynchronous sort of like situations. So I think that'll work really well for, the WebSocket connection. So part of this is I'm quite familiar with like this ecosystem, but also like I think this is going to work really well just for this setup. And then basically, so we give it a list of tasks, and then we start everything up here. So you can see here, yield parallel. So we basically have all these tasks running in parallel. And this actually we're like literally writing a loop. So every time we receive an event, so will take any action that's fired off, and then log it out. So we'll see a log of any time we make any changes, based on the fact that we've got this conditionally turned on. And then we get the store. Okay. Seems like you could do that. Seems like you could do that in Tauri. Yeah. Okay. So this bit, we will be using Tauri. We will be using that Tauri API that we wrote last time with the file system setup, but we're just going to put it within Starfx and basically have Starfx be the thing that reads and writes, or is the trigger to read and write to that same API that we had set up before. How do you minimize data storage between the Rust backend and the JavaScript front end? Yeah, that's definitely an interesting question. And it's actually something that's kind of come up as I've been using this as well, because like you want to have one source of truth, right? So if you have multiple copies of the data, then it starts to become difficult to manage and know which is going to be the one that you need to pull data from, but also like keeping track of and updating every one of those pieces of state is awful. In this case, we don't really have a strong need to have anything stored in a Rust state. So there's actually like state in your Tauri app on the Rust side of things. There's like a place where you can store state there. We're also using the Tauri API to read and write to the actual file system. So that's kind of state as well. And that's why something like this is nice, because by writing a persister, that is going to handle that syncing. So we don't really have state. In this case, we don't have state in Rust. We have state like in the file system that's being pulled and written through Rust. And then we have our like in-memory state. This persister, well, we'll have to write a custom one, but this API will allow us to write it once and then it will handle it for us. So I think that's probably the important part when you're trying to decide where to store state. If you put it in Rust, the benefit of doing it in Rust is potentially it's more opaque to users. Like if there's more security considerations, it's probably better to put it in the Rust side of things. But also the Rust side of things can communicate and is that go between for pushing data to any windows. So if you have multiple windows and those windows need to store or see the same state, it might make sense to put it in Rust, because then you're not trying to figure out how to copy data between all these different windows, because you can think of a window like a browser tab, right? That just sounds awful. So that's probably the thing that I've found is going to be the most direct decision maker. If you're using multiple windows, it's going to make much more sense to actually store the state in Rust. Most JavaScript libraries that you'll pull in are expecting to run in a browser and not have Rust backend. So it might be, with those libraries, more convenient to just store it in the browser. So once you like decide where that state is stored, then you need to start thinking about persisting, which also kind of comes into the question, brings up the question as well. So in this case, this is handling our persisted state, saving it out to the file system, and it's also handling the like in-memory state. So it's doing both of those for us, which is super convenient. And that's part of the reason that it feels like it's going to work pretty well for this. You could print your context providers to a store that all windows could share. Yes. So effectively, you could do like a like I've seen folks use WebSocket connections to talk to the store, or you can use the like built-in IPC layer and events. So when a view loads, it can call a command or something to get the data that's actually stored within the Rust side of things. So then, like once you've decided like where to put it, then you have to figure out like how you want to store it. If you're deciding to store it in Rust, then you need to figure out how you're doing that and how you're persisting it. So that could be like a SQLite database, that could be in memory, like using the store. There's a state plugin, there's the file system plugins. There's a big problem when using Electron. You had an application that holds state in a Go binary, some in Electron backend and copies of it in the front end. Yes. Ideally, as it seems pretty clear that you found, it's best to avoid that. How you avoid that is definitely the bigger question. The Go binary thing sounds like it could complicate things, but I would definitely say in that case, try to keep as much of it out of the front end as possible. So at least you're only syncing it between Rust and Go. But in that case, so in that case, if you're holding your source of truth, we'll call it your source of truth in Rust or in Go, those might need to communicate with each other. But then your front end is always just going to be a view layer. It might be showing that exact state pulled from Rust, or it's a derivation of. And you'll actually see the derivation of a little bit in here too. You're hooking up to Postgres right now, Tauri, then you can start in the charting functions. Yeah, and there's like we looked at PG Lite on the stream too, which is a smaller, intended to be run like within the browser too, library that is basically like Postgres, but SQLite equivalent. That's another way to do it too. If you're already going to have some sort of like sync engine, you could have more of a database thing living in Rust that also syncs to each of the browser tabs. But you don't want to be replicating the data too much either. So showing derived data is probably not an issue. But if you're putting state in Rust and then syncing it to each of the windows, you potentially have like, 4 or 5 copies. So it's not there's no real easy answer. I think again, coming back around to, I think the most general answer is if you're having multi-windows, it's going to make more sense to store more state in Rust, because that has everything can kind of talk more directly to that. All right, so I'm going to take off. Well, we're not going to worry about that right now, actually. Let's copy a little bit more, and we'll kind of talk through the rest here. I guess we'll pull this in. We'll end up just ripping out a whole ton of it. What did we call it? We called it schema. So you'll see in this code that we're looking at and pulling in, there's a fair amount of like we pulled in Dinero. Dinero is a pretty neat library that handles transactions, or that he handles currency. what has been very complex about writing this app that we're pulling information from, this finance app. Dates are hard. Currency is hard, especially when you're doing international for both of them. I think I've actually got most of it working. I haven't dug too deep in actually like enabling all the internationalization, So as folks start to ask more about that, we'll probably push on that a little bit, but we have all the foundation there because both the Nero and the date functions that we have and the calendar setups that we have all support internationalization. So there's a lot of like helpers, and when you persist the state, you need to then serialize it in and out. It's not insignificant. A finance app feels like it would be easy. That feeling is wrong. It is not. That's the easiest way to go about it. So like here we got starting a date, and then we're starting to pull in date functions already from the root here. All we really care about though is this bit. So we're gonna just rip out all of these types, and then we're gonna just start fresh here. With Starfx, at least with the Immer.js setup, there's an expectation that you have cache unloaders. We're not really going to use them too much, but TypeScript will complain if we don't, so we're just going to leave them in there for now. Now, we're going to have like 2 bits to deal with here. There is the file itself, and that'll be the sort of like that root tab. We've called it, I think we just called it the tab. So I guess we say we'll call it stream, and that's going to be a slice table. And then we have to do, and that's also going to be a slice table. Table is effectively like these are the options, the types of slices. So everything else is more primitive. A table is effectively like an object. It's an array of objects. The massive amounts of data you need to deal with. Heck, Coinvoice says over 900 projects. Yeah, so what's actually kind of interesting about what I've been pushing for on Finata is that it's future. It's future thinking, cash flow analysis. So we're starting to get into like financial terms here, but pretty much like, I don't know, like 98% of the apps that I've seen out there for personal finance, at least, they're all purely historical. They're trying to figure out some way to like pull in this huge amount of data from all of your different banks, investments, et cetera, and then like get some data out of it. I feel like in every one of those systems, you just spend a whole ton of time trying to make the data good enough to actually make using those charts worthwhile. But by the time I've done that, I don't actually like get any value out of it. So I spend all my time trying to fix the data that's coming in, and then don't actually even look at the charts. So the idea here is that you describe your budget and what you're expecting these expenditures to be, and then we're projecting forward. So we don't actually need a whole ton of data, which is actually where it starts to make it a little bit more interesting, because as far as data ownership goes, if you have, a 1 kilobyte file that's literally describing all of your planned expenditures, that can be stored anywhere, right? So we can sync that anywhere. Like that, we can sync your whole chunk of data, and we can put it on every device that you have. Obviously, we would want like encrypted and such, but I think it's a better system, especially for personal finance. It's actually a bigger deal in like corporate type finance, like projections, yearly projections and all that stuff. That's literally like using this type of work. I think some of it is like it feels complex, and that's why it hasn't trickled down into like the personal finance space. But I feel like it's a better way to think about things personally. So yes, generally there's a massive amount of data that you're dealing with, not in what we're doing with Finata, which is why using something like this ends up being perfectly fine, because we can store the state pretty cleanly. All right, so we've got this stream. Do we make these plural? I guess we say streams and to-dos. Those will be slice.table. We're going to give them a little bit of typing. Let's close some things here, and we're going to pull up what we were doing before. What are the fields that we got? We're not in Tauri. We want to look at, I guess, tabs. So we had an ID, a title, string, and content. What are we doing with the content? So item key, tab panels. I think the thing that we really care about is just ID, title, and like file maybe. So we'll say we're gonna do an interface. If you've used TypeScript at all, the best advice that I've seen in working with TypeScript, you can make a type or you can make an interface. Interfaces seem to be a good default because you can extend them. If you are writing a type, you can write a very focused type as an interface, and then you can build on top of it. So we can have a file interface, and then we can build on top of that file interface. So our stream text file extends file. So just the ability to extend and build on top of existing interfaces is really nice. So I tend to use interface as my default for TypeScript types, at least the more complex ones, the non-primitive ones. So we want to do, we'll say streams, I guess, interface streams. And we'll basically just dump this in here, I think, for right now. We can always build up on it as we go. And then we need the to-do list. We have some of that already. What is, okay, so to-do item is this. Interface to-do. Yeah. I accidentally hit Control C rather than V. I think I'm actually going to do this. Whoop. It feels weird, and I'm going to make these singular because this is a single stream and this is a single to-do. All right, so this is our kind of our initial setup here, and then we've got, is there anything else that we need to pull in? We have the setup, the schema, and the factory. Factory is just was a helper to give me some root values, which I don't really need here. We might need to pull in like the reconciler, but I think everything else is we can sort of set aside. Other than, I think I'm gonna pull in this. Yeah, we're gonna pull in this foundation.ts. So within Starfx, we have sort of like two groups of helper functions, maybe would be the way to call it. Funcs and potentially the APIs if you're using that the API which is basically just thunks with more middleware like pre setup. Thunks are the thing that's doing an action. The selector is pulling the data back. And what's cool about the selectors is it's got like built-in memoization. It uses reselect.js, and you create a selector and you can extend selectors. So you can like build, so you can have selectors refer to selectors. So we can derive data on multiple layers, and it does all the memoization for us. And all that updating and everything, we just say, we want to use this, show it in our view, which ends up makes our views like really super clean. And then they're performant too because it does the memoization. If you're not familiar with the term, memoization would be a way to save data, and when your data changes, rather than always recalculating the derived data, we can know if your data changed in a way that's going to affect that computation. So we can save the computation and only update it if we need to. If your data changes in a way that's going to affect it, then it will recalculate it. Otherwise, it's just going to no op. It'll do no operation, and that ends up being performant, especially if you have a global state where things are changing often. A change in the global state doesn't mean everything needs to change and update. So we've got thunks. We're doing the foundation thunks/foundation.ts. So I'm gonna drop this in here, and this is sort of like setting up that like little helper bit. The thunks.use are all the different middlewares, and then in our setup, we need to initial state, schema. We don't have these. We don't care about those. Why can't you find it? We're going to have to fix this one. I'm going to just take this out for right now, including our local persister. Actually, here, no. We'll keep the local persister in there. We'll do this, and I think we can just remove the reconciler and just use the default one for the moment. Now, why are you not working? We will do the index, because that's just re-exporting all these little bits. And index.ts. Okay. This is done so as to wire up all of these to the setup. All right. So we don't need any of these right now. We'll take all that out. Why are you still not working? Let's just reload and see if it finds it now. Yes. Okay. Actually, here I'm gonna just comment it out so we have a reference to it. Now, I think we're all set. Now we just need to start putting it in there. If we look at our app route here, we have a nope, that would be the router. Here, we should add in this provider. So this provider comes from Starfx React, and that uses the schema in store, which we set up right here. So let's pull that in, and then we should be able to start pulling stuff in from there. So in our main, we have this disables the menu when you click into it, that little pop-up autocomplete functionality. That just hides it. Menu items, we might end up using these eventually, so we'll leave that in there for the moment. And then we've got init Tauri, so this is our tray stuff, and then we're creating the root and passing in those APIs. So similarly, we need to do this, except I think we're going to pull in this provider. I'll just do this for the moment. Oh, that's not going to work. Oh, I'm doing it within there. So we just need this. We're going to wrap this, and it'll be just fine here. Why are you complaining? One parent element. Oh, it added this in for me. Trying to be helpful. You're trying to be helpful, I can see, but would it be possible for you to explain the logic with the schema? Sure. What is there a specific piece of it that is not super clear? Are you talking about the schema that we've set up and we're planning to use here? Disable menu and then tray here. Okay. We don't have a Supabase, but we have these bits. Oh, then we need the provider import. This. What are we complaining about here? Property children is missing. Provider cannot be used as a JS component. We might need to shift this a little bit. I suppose I could. I mean, I don't know if I like this async init thing, but it's using the create root from React DOM client. That's what we're using here too, right? Yeah. Okay. I don't think that's gonna matter. We struck this in there, so then that is for sure defined, which also feels a little bit weird, but let's pull this up here. Here's our store, and this kind of comes back to the logic with the schema. Streams and to-dos, it ends up being a record. As far as TypeScript types go, it's basically an object, which we can then, from that object, we can pull out either an array or we can pull out the actual object itself. And then we'll write the selectors to make that process easier in the actual view layer itself. Provider cannot be used as a I don't see like we're giving it a. I don't really want to add in strict mode because that always ends up running into issues for the stuff that we're working on because we don't. Yeah. Okay. Why would that work? What are we complaining about here? Okay, we're gonna try the reload. I don't see what the actual issue is here. Is not assignable to type React node promise React node. It must be a. Do we have a? What do our types look like here? Yeah. Okay. This needs to be 18.3.18. Oh, 18.3.18. What does this need to be? This needs to be 18.3.5. Okay. npm install. The thing that I like when using TypeScript, it feels a little bit more in the vein of like Rust, where I'm not even running the server. I'm not even checking what I'm doing in the browser. I'm just making sure my types work. I'm putting all the code in there, making sure the types work, and that catches all those like little errors that I feel like I used to do by just rendering it and hitting refresh and seeing what broke. The problem is if things aren't well typed all the way through and you have an any anywhere, I don't actually see any that we're doing right now, which is good. it blitzes everything. So it's like, it feels like it's safe, but it's not really safe. That's probably one of the biggest differences between writing JavaScript, or excuse me, writing TypeScript in Rust. Rust actually enforces it. Okay. So we got that. We got everything set up. Let's start pulling in stuff to render it, and then we'll run the actual app itself. So we only have 2 pages here. We have the app. So we got our system tray context provider. And actually, I suppose we could set it up here. React Spectrum provider comes from React Spectrum. That is more with for doing like React's daily stuff. And it might get a little weird with React Spectrum seems to be built around using React's daily. So we might need to like play around with that a little bit, but we'll make it work. So speaking of writing out files, that's where we're doing it here, including changing our tabs. But all we're doing here is rendering. So there's 2 bits we can do here. We want to show the content, but then we also want to have actions. So we're going to, we have a tabs, and this tabs is effectively the thing that's the store right now. So we're using async list, and that is our, you can see we're importing from React Stately. This we're going to effectively swap out. So I think we'll try going like this, and we'll say use selector. Use selector is the bit from, why aren't you, oh, it imported already, okay. Use selector is the bit from Starfx, which uses reselect to pull in the data. It needs 1 to 2 arguments. We're going to give it basically a selector. So in this case, I think we just want to do like a schema.tabs. I guess we just want a list, right? So let's import this so we get some types helping us out. And we'll say tabs.sol. Oh, is it? No, it's not tabs. It is, let's go back to our schema. Streams. Select table as list. So that's all we need to do to basically give us the equivalent here. I hear a car alarm going off. I thought it was my music at first. Must be the neighbors. So kind of coming back to your question here, date or numero. Well, we're gonna just say numero. Did I try pronouncing your avatar handle, whatever you call it, last time? I'm trying to remember what I said last time. Numero. We have a schema. The schema represents 2 pieces. We'll run the app in a second, so it'll make it a little bit clearer. But we have tabs up at the top, and each tab represents a specific stream that we care about. And then within each stream, we have basically the to-do items that we'll be going through on that stream. Typically, we're only going to be looking at 1 tab. So interacting with that functionality is not going to happen that much. Most of what we care about is going to just be our to-do items, which is going to be pretty generic, as you'd expect with to-do items. So this should give us a list of tabs, at least as far as this state is concerned. So now we'll do that for right now. And you can see here now we're getting some errors, which makes sense. We don't have a loading state anymore. This is going to just be giving us the So it's like, in some ways it's technically async, but one of the interesting things about generators is it can run things, if possible, as synchronous. So it allows you to sort of like mix synchronous with asynchronous. So it doesn't, you don't get this like, when you're using async await, it's kind of infectious. Once you make a part of it async, like everything ends up becoming async. You don't have to do that when you're using generators, at least with affection, which is really nice. So this loading state, we don't really need to worry about that as much, because some of that ends up just sort of being handled at the at other layers. So this will give us at least some bits to work off of. We're just going to do this. I want to get a good load here, and then we will go from there. So this is doing a use callback, and anytime tab changes, then that will update, which makes sense to me. We're going to do that. So then at least we'll get property file ops does not exist on stream. Okay, so coming back to the schema, we have defined our schema here. We get the TypeScript helping us out. There's no file operations on tab, which makes sense. So we could say, I think what we're going to do is we're going to say this is going to be a file name. Each one of these streams is always going to be saved to a file. We're just going to call it a string because that's how we've been dealing with it. I don't think these matter too much. So we're not going to actually save those in state for the moment. And we're going to say, we're just going to go like this. To do, actually, well, what do we call it? Name tab dot file name, and where do we have this defined? File ops. Do we have that? We don't have that type anywhere, do we? It must be in here. Property options is missing a type. Okay, well. Sure. Oh, well, it's not audio, but, you tried. Okay. That I think is going to give us something that renders. Let's go ahead and start up our dev server here, and we'll see what's happening. Does that help at all with the schema? It might be a little bit clearer once we see. Let me know, Nomero. Oh, okay. It is still loading. Okay, so this is going to be the other bit. When we use React stately, yeah, okay. We sort of have this built-in expectation that we have a default, which we don't. I think actually what we do here, this is going to be, this is actually going to kind of work out well for us. In this case, we have a default. one of the things that what is that expecting? Okay. One of the expectations with, well, not expectation, but one of the ways Starfx thinks about hitting APIs, before you've like set up your local state, your state is effectively like undefined, right? Or like an empty array, and then you need to put in all of these within your code checks to, is your data undefined or have you actually like gotten any data in there yet? So one of the options that it does is allow you to give it an empty value, and it will use that if you have no data in the state. So rather than saying undefined, it will show this empty value, which means that in some cases it'll make your rendering and your view layer cleaner because you don't have to like worry about this potential state where things are just not defined. So we're gonna go like this. I think it's expecting a record. Empty. What is it not like it? It comes to the property empty, which is declared initial state and empty. So it needs a stream, and stream will be this. Oh, do we need a file name? File name. We have an ID, we have a title, and we have a file name. Now, what are we missing? Maybe I was wrong about that. Maybe it does actually have it specified this way. There we go. Okay. So now we're just going to refresh, do a hard refresh here. Do we have any errors? No errors yet. That's still not rendering. Let us log out our tabs. Okay, so we have an empty array. That makes sense. Why aren't we getting this one though? Streams to do. Streams, select table as list. I think for the table, I don't remember the logic for it. I don't use this empty state very often. I was thinking it would give us an actual value there. Okay. Let's just switch this to the initial state then. And this is where we need it, like this, I believe. Refresh. Tabs. Streams initial state. Why don't we have any tabs? Schema.streams.select table as list. I think we've got everything wired up here fine. We don't have any tasks. We don't have any thunks. We have our schema initial state. Exporting those. I'm just making sure I didn't accidentally delete something. So we're starting up our thunks. The thunks are basically like they're all like ongoing functions that are effectively like listeners. So we're putting up our thunks and our tasks, and then we rehydrate from local persister. We could probably take that off for the moment. I don't know if that's having any effect here. There we go. Yep. We'll have to come back to that. And I don't really want the local storage persister anyway, so that's not an issue. Okay, so it was trying to persist the state, which we didn't have any initially, so it was we're getting some like weird confusion there. Actually, I guess while we're talking about that, could we actually go back to? Whoop, I'm gonna save this or copy this, and we're gonna try empty. Is that actually gonna work now with Okay, so I was wrong about the empty for sliced out table. All right, so we have a default. Now when we click the plus, we're not doing anything. We've commented out all of the add tab stuff. So what this is doing is it is opening up the file, doing to do things, and then writing and closing. That's a lot of stuff in our view and tied to the view, which is kind of annoying. So what we're going to do instead is say streams.ts, and we're gonna add a thunk for this. I'm gonna go here and just copy a little bit so we have some code to look off of. This is probably the smallest here. Yeah, that'll work. Okay, so what we're doing is we write a thunk, so thunks.create. We give it some expected payload input, and then we do all the logic here. And now this ends up becoming like a reusable piece, which would be kind of nice. Would it be more efficient to use Rust MPSC channel to group data for TS update if there is data? I feel like there's a lot in that question, and I don't know that I'm catching all of it. You might need to say a little bit more. Rust MPSC channel, that's not the like you're not talking about the channel integration with shoot, what is it? The Tauri channels, right? If we look at like one of these here channels, we're not talking about this channel, right? Different channel, correct? I don't know that it's going to make a difference, and I don't that sounds like it could potentially be more involved. All we're doing here is writing out and reading in memory state, and then as a separate operation tied to those, we are saving and persisting to that file. I can remove the scroll bar in a Tauri v2 app. So like this dealio, right? I think that's just going to be a CSS thing. We have, oh, I can't actually change the size of this window here because I've got that turned off. But in our CSS, we set a zoom, and is that the only CSS we have now? I guess so. Like if we change this to 100%, you can see it goes away. So as long as the content is not bigger than the window, then it will not show a scroll bar. And your CSS, you can make the window height as big as it needs to be. Like that, I mean, that's browser functionality, right? If you need a scroll bar and you have the scroll bars turned on, then it'll show it. So like overflow is what you're looking for. There's a overflow hidden would be the other way to do it. So anything that goes outside the container, if you say hidden, it's just gonna like clip it off and you're not gonna be able to see it at all. You need to think about it obviously when you're writing your app, because if somebody makes the window a size where that is not visible and they don't have a way to scroll to see it, then they are stuck. So when you were making an app using Tauri v2, you applied the scroll area of SHAD CI or SHAD CI, but the basic scroll bar and the scroll bar of SHAD CN are created at the same time. So yeah. We're using, I guess technically we're using a React Spectrum for the bulk of our CSS here. So that I've used Tailwind quite a bit. It's one of those things that, like, if you abstract out and have somebody else deal with the CSS for you, you don't necessarily think of it until it bites you. So if you're hand rolling your CSS, this kind of thing would be a little bit more obvious, potentially. But yeah, it's a CSS thing. So again, you just need to same as if you're working with the browser, you need to make sure that if you're hiding that scroll bar, compensate for it in your app. Okay, so now if we hit plus, it's not doing anything right now because we need a thunk. We started to pull in and write our thunk. We're here. So within our thunk, we can get a payload, and then we can act on that payload. Now we can do whatever we want with it, such as putting or updating our schema. So we can change or mute. Well, the state's immutable. It's using image.js, which acts like mutation, but it actually does under the hood changes as an immutable change. So we can do this dot set, and it's not actually mutating state; it's changing state over time. Blah 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 blah. So we can do the state things here and have all that state contained here. And what's been nice is it's not. If you've used React and React Redux in the past, writing the reducers ended up being quite a bit of boilerplate. They've added toolkits and such, so like that's not as big of a deal as it used to be. So even if you're using React Redux directly, that's not nearly as verbose as it could be. But same thing here in React or with Starfx. A little bit of code, but it's not anything too involved. So we want to, when we click on this is the tabs component. We want to look, nope, we're getting too many tabs open here. Okay, so we want to figure out a name. And that name will then define. So we actually don't take any input. We don't need any input here. So I'm actually going to do this. And we're going to call it add stream. Sure. We're actually going to say stream add. This is, we'll see when we start using these functions, they're going to log out to the console because we have that set up. I've found this feels nice. So the log will have an ID attached to it, and we'll basically see this thunk running in that log. When we do that, we want to do a schema update, and we are going to say schema.streams. And I suppose we could also do this in, maybe we actually just do this directly in the view for the moment. We could. Yes, let's do it. We're going to use the dispatch API for the moment, because this is a rather straightforward thing. We're just kicking off a bit of work, and we can directly tied here. So rather than doing an add tab here, we're going to say add tab, and we're going to say a dispatch. We do need to do a const dispatch equals use dispatch. This will give us a helper where we can dispatch any action. We have some built-in actions just by the fact that we're using a table. So we're going to do a streams.todo.add. We are going to be adding a record, and the record is going to be of ID something, and it will have that state. And this is effectively where we're going to have this little bit of a logic here. We probably could pull this out because there is a little bit of extra logic here. So actually, I'm gonna go back on what I was saying. We're gonna use add tab. We're gonna do this. So now we're gonna say name. Name is going to be our ID. And then basically these bits here. So ID is name. And then title is name. And that, and save. File name we need. File name is going to be this. So now it will, and you can see how this has kind of like cleaned up our code a little bit here. All of this file system operation type stuff, we're going to be able to pipe that away into the persister itself. So now when we do this, we should be getting an event firing off. So let's do add. Oh, we can see here we're firing off an event. It is doing a dispatch on schema.streams.add. Do we? I guess we can keep it async. I mean, I don't really need it to be async anymore. Maybe we take that off. Okay, so we're getting a log. We're dispatching. I'm not using dispatch wrong, am I? So we still have the default there. This feels fine. But we're not getting it refreshing. So we're not seeing tabs again. Okay, we're going to, it might be this like use callback thing too. We don't actually really need that anymore either. So let's just do this. Because really it's a small enough amount of code that we can just do that now. And okay, so it's definitely doing the same state thing. Am I using dispatch wrong? We look at some of this other code that I've written. We can go to, let's see, where would be a good place to look? No, actually, it's going to probably be from our forms. Pages, components, forms. And we have a use dispatch. On submit, we do a dispatch. And then we do, so in this case, we're actually doing a in action. So transaction add. It's late where you are. Came to say hi. Appreciate it. Thanks for watching. Good to see you. Good to see you as always. Sleep well. Okay. So why is it not firing? We're calling a dispatch, and we're calling it on an action. I think I'm using actions for all of these. I don't know that I have a good example. Let's go back here real quick, and we'll look at the dispatch API here. So we're dispatching store.dispatch. Dispatch type click. I feel like I'm using the use dispatch wrong. Because it's gonna end up being this, but I think that serializes into it. Maybe we just maybe we just write an action because that's what I've done, and I know I can get that to work. I know this helper works though. I'm doing something a little bit wrong here. Loaders, FX, structure concurrency, supervisors. Here the FX, you can see the task parallel thing that we were talking about. It's 3 a.m. in there. Yeah, I stream earlier, so folks way east of me can actually check in live. And then it's early for folks in the US, but not like awful. But that's also why we do it on YouTube, because then you have something to come back to and watch. You can catch up after you get some sleep. Hey Gabriel, good to see you. Thanks for stopping by. All right. Why isn't this dispatch working? South Korea, nice. All right, we are. So we're definitely firing that off, right? Because we're seeing the state come through. It's coming through, and we're seeing it in the log. So the setup.ts on line 57 here, we'll zoom in a bit. Setup.ts on line 57 is our state coming through, and we're logging it out. So we're logging out that action. But okay, schema.streams.add. The APIs are slightly different when you use it in the view versus when you write it in an action. This is how I'd write it when I was writing it in an action, and I think I'm mixing up the two. Dispatch takes do we need to do it as a function? Add. Well, it's still doing the same thing. Okay, I might just say we'll say screw it and write it as a separate thing. I don't know what I'm holding. I'm holding something wrong. Yep. Okay, we're gonna do it. I'm over it. I have a feeling we'll end up putting more stuff here anyways, so like that's part of the reason I don't feel bad about it, I guess. So we'll do this song and dance again. We'll remove all these bits that I don't care as much about. So you can see here that like this is kind of what I was doing. I was doing a schema update. which is a little bit different than if you're using with the dispatch. I'm pretty certain you can do the inline dispatch, though. I just am missing something, and I don't feel like figuring it out right now. Welcome to programming. You spend hours trying to debug the thing, and then it finally works, and you're like, all right, great. Next thing. What's the next issue now? So we'll do an add stream. Oh, actually, I was going to do this as stream add, right? So we'll have a schema dot. We can actually just copy this bit here. We're going to do this. This is going to go here. And we're going to do this. And that is going to go here. So now we can just do an add stream. And we're going to say dispatch. Was that? I wonder if I was actually running it or not. Import. There we go. And you can see we're more and more we're pulling out code from our actual. I can leave that in there for now. We're pulling out more and more code from the actual view. So we're sort of like separating out the things that mutate or change our state. Add tab is not a function. All right, what am I doing now? Oh, do I need to do one of these dealios? Whoop, whoop, whoop. Okay. Is it? So we're still getting that same log, right? We're doing a schema.streams.add. And what does this end up looking like? We're going to call this an entry. Is this just malformed? Is that the reason that we were having troubles here? Console.log entry. Export star from streams. Whoop. Stream.ts. Okay. Now we need that because it needs to. We're getting the payload, right? Patches, add, operation add. Oh, no, that's the initial one, right? So we'll do that. If we clear that, and now when we click this. Okay, I'm missing something little. What is the question? We have an initial state. We have a store. We're doing a store.run. Yield group. Okay, we're running tasks in parallel. We're booting up our thunks. Our thunks come from. I don't think I've got the thunks actually starting up correctly. I think maybe what we had before was actually working. This is the bit that as we've been working through things in Starfx, so the person that started it, they're also in the front side Discord, and I use both of these libraries, so I've kind of collaborating on all of it. The thing that we've kind of been working through is once you get it wired up, it works fine. But if you miss like one of these little steps, it's not always obvious. And some of this I've like specifically set up my functions so it's more obvious when I miss it. But there's still these little pieces where, so we're doing tasks, thunks, and then the auth. So we're running these tasks. This schema.update, that's the thing that you see when it first loads. And we have thunks. The index is, we're exporting the thunks and tasks. And then in any of our like import, we import from foundation the thunks. And there, like, there's a little bit of that like loading order persistence type things that like it needs to, if things run out of order, then it doesn't work. But also it's done because that is convenient. It's convenient to import and export directly from the files. So what the heck am I missing? We have an import from thunks. We have an import from schema. It should be firing off that function, and it's calling next. Next is the in the vein of like other Express middlewares, etc. We'd be fire off and go to the next middleware. We're not doing something. We're not getting a weird error here, are we? That's just being swallowed. Refresh. Yeah, we're not getting that. We're not hitting this thunk at all. So let's go into our home. We have this use tab. We're not really doing that anymore. Let's double check our dispatch. Look at one of the examples and make sure we are dispatching correctly. It could very well be that we've got an error and TypeScript isn't catching it because our TypeScript isn't like fully formed in this example project. I mean, not example, but like we might have TypeScript errors there, and that might be part of the reason we're running into issues. So what we're doing is we're doing a use dispatch, and we're calling dispatch transaction add value. That's what we got to do. I think I can take this off though, because I don't actually need a function calling another function. Whoa, nope, never mind. We need it. We're getting an infinite loop there. Stop. Okay. Shh. We'll just restart it. So that, I think that's what we were missing before too. If we did the add inline. Well, we were calling it, weren't we? I don't know. There we go. Store is updated. We can flip back and forth. Bam, we got that rolling. Okay, so we will come back to the file operation stuff. I want to get the to-do items wired up real quick here. So now we got a thunk for stream. And like all this code's gonna end up going away. I guess while we're at it, we might as well do a remove. So we'll say a remove stream remove. That is going to take in ID of type string. And now we can say the context is going to have a payload. So we're going to say const ID equals context. We don't need any of these bits. So we can do a schema.streams.remove, and we are removing ID. ID does not exist. What do you take? You take IDs. There we go. And property ID does not exist on, context dot payload. There we go. So remove takes an array. Remove IDs. IDs is an array of ID prop, which are just the IDs. Okay, and now we can get rid of these logs because we're gonna already have some logs wired up. And this will give us the same. Dispatch remove stream and or remove tab. And it is going to be using tab value. And what is tab value implicitly as an any type? Sure. String, right? So that means we can get rid of u. And I'm going to keep this, well, we'll be able to remove this, but I'm going to keep it in there just for the moment because I want to be able to then copy it and paste it into the persister. And we'll go from there. Oh, remove stream. There we go. Okay. Now we want to do the same for our to-dos. Paste. We'll say to do, and we're going to do an add to do. I capitalized it like that, which for better or worse. Remove is going to be the same to-dos. Like this function will be pretty much the same here, so we don't need to do too much. This is going to change a little bit though, in which we'll probably need to come back to that, but in a second. Oh no! What did I do here? I flip-flopped him. Okay. Let's just rename him. Trying to go quick. It's biting me. I copy pasted and then I edited the wrong one. I thought it was on the other tab. Okay. Our home should be good. Our tabs. This isn't really going to change. It's all just showing the same data and everything. We don't need schema open right now, so let's close that, and we'll close that, and then we'll pull over the to-do list. And this is going to end up updating a little bit. Why are you complaining? Did I delete something? To-do does not provide an export. Oh. Because I renamed. So we need to do an index from this. We'll do a stream. And then in here, that's not a problem, but in here we need to update this to be from stream. There we go. Okay. So now this is taking a list ID and file operations. And then we have the selected keys. Now this is interesting because it's got this selected key state. I don't think we're gonna bother with this. I'm fine having like local state as we select bits. But in this case, I think we actually want to track if they're checked. So I lied. We're gonna come back to our schema here. We have a to do, and we do have a checked state on there already. So both of these I think are going to be I think we're going to replace both of those. Equals use selector. And we're going to do a schema dot to-dos dot select table as list. Same deal. The handle, what do we got here? We got a on callback, right? Why are you? There we go. And then we want this and this. We're not going to actually run any actions, just like do your thing right now. We're going to replace all the to-do.items. And then this, like we had this weird, when we were doing selection changes, how it was handling the state was kind of odd. I don't know if we're going to need to replace, like if that is going to go away. That could just very well just go away, which would be nice. Because it was kind of kludgy. Like we had to get in current items, and then we were doing some work in the middle of it to actually save the existing state, which was awkward. But you know. Okay, so to do is not defined. We need a to do loading state. We don't have loading state. Selected keys. I guess that's going to be we're just going to say an empty array for right now, because we're not going to bother with any selections. So hello. That makes sense. Add's not doing anything because we don't have that wired up. We're probably still going to need to use those, so we'll leave those there. And now we need to do the handle submit. So every time we fill in the form, it's going to do this thing. We were doing the handle submit because this is, as far as it's aware, a form, and we're doing on submit here. So we don't need to do async await. We are going to directly in here say prevent default, and then we're going to call our selectors and such. Or excuse me, we're going to call our dispatch of the actions. So that's going to end up cleaning up a bunch of this. Dispatch equals use dispatch. And we're going to do an add. Add to do. Now add to do is going to take the event Okay, so this will be our actual like value. Item does not. Were we just like ignoring that before? We'll try that and we'll see what happens. But we want to call it dispatch add to do and this. Whoop. So now we just need the text, I think, right? That's the only thing that we actually care about. Because it's going to come in as unchecked by default. So we really only need to do a to-do item text. And here in our payload, we'll end up saying, oh, I am just fat fingering everything here. There we go. Moved my keyboard a little bit. That helps. This will be content, I guess. Content is string. We're going to get a to-do item, something like this. The content will be from context.payload. This bytes to base 64 we can pull in here. So now we have a content, we have a to-do item, and this is to-do item. In this case, we're just directly appending it. And then here, this bit is just to write it out to the file, which we're going to be doing again. We're going to be doing that separately. So then this will be a to-dos dot add, and we are going to be adding the to-do item. Now this needs to be like this. So to-do item dot ID, because we're adding it as an object effectively. That's I think more due to Immer than anything. Immer.js being the immutable state library. All right, so now, hello. Something is coming up. Progress. So we don't need this anymore. We are dispatching an event. Let's log out this. I have a feeling that we're not actually getting the value in, which is part of our event dot target. Hello. So like if we look at our payload, we are getting we're not getting any value there. So I want to see the actual, that form. Let's just do value. I think it might just be value. Hi. Okay, so now it's just completely undefined. I thought there was a way to like, just log out the whole event. Here, we'll hard code it for now, and then we're going to do a console.log event. And then we can actually inspect it. The target stuff is what we need, but it's confusing things a little bit here. Add to do. Oh, so this is part of it. We need to pass it in like this, right? Content. There we go. So now if we look, let's just double check to make sure our event dot target dot, we're looking at value. There's no value. Is it an item then? Last child item, because that's what we had in there before. Inner text. Okay. We're part of the way there. Enter item. It must actually, like, that must actually have been right. So if we do event dot target dot item dot value. There we go. Okay. So we're dispatching, we're getting the event. It is coming in, and now we want to add in the remove. So you have an on submit, and then we want a delete. So on delete, we are calling the handle delete. So we don't need this anymore. Action key is going to be a key. So I think we can go like this and do a ID of this. I can probably go like this. I think that'll work fine. Just to use the shorthand syntax and reduce the amount of code that we have written there. Only specify known properties. Oh, yes, we need to do, this should be a remove to do. And type key is not assignable to type string. So a key could also be a number. So this could be string or number, which should be perfectly fine for here. Okay. Now that means our handle delete goes away. We still need to change, or we need to deal with the handle selection change. But we're getting there. This can go away. We're not going to use the selected keys. We're not going to use any of the use list. We've done the handle submit. Again, though, I'm going to leave it here because we want to have the right text file piece. We need to do that. So that'll be our like to do. That'll be our to do item. And then let's see, set selected keys. And selection. Well, like, what does that look? Okay, so it's all or a key. That's a little bit annoying to deal with. At least not convenient. So we want to do here. This is going to be a change. I don't think the to-dos actually matter. We're going to do something similar though here. We're going to say dispatch remove to do, and instead of remove, we're going to have a set to do selection. So now that is going to take a change, and change is going to be selection, and that selection is going to come from It says it comes from React Stately. I guess we are using React Stately just by using this library. Hey, Job, good to see you. Good to see you as always. I don't know, I guess. Do we import, is it also in the React Spectrum? Because that would be nice. It would be nice to just like completely remove. Okay, it does seem to be part of that. It would be nice to remove that as a direct dependency at least. So now that should come in. It's going to come in as a change. We have now a, this will be a selection. So we're going to have a code path here. So we're going to say if change equals all, then we're going to do a thing. Else, we're going to do the other thing. And it's going to be something in the vein of one of these. And then we're going to call next. So depending on what we're passing in for the change, we're going to handle it two different ways. You know that they rewrite SQLite in Rust. I saw, I mean, there's a handful of implementations now. I saw that some folks have decided to, basically do a rewrite in Rust. Like it's a port. So you still end up having to maintain both in parallel. I don't think they've actually done like bindings directly to the, what is it, written in C, I think, or something? I don't remember what SQLite is written in. So the like feature parity is always going to be part of the question. But yeah, what is it? Like lib SQLite or something like that? I don't remember. So there's like a bunch of those projects now. I think PG Lite is also written in Rust. It's kind of cool though. Yeah, I'm down for it. It seems like more and more things are sort of being rewritten in Rust, and that's starting to leak into the Linux kernel and Linux ecosystem a little bit more, which is exciting to see. Partly because I like the interop, but also like memory safety is nice. Obviously, for the folk that are very familiar with other languages, it's not ideal for them. So you're never going to be able to convince everybody that is a perfect situation, but it is what it is. All right. So we have a schema.todos. We're not removing. We are doing a set. All right. So there we can select or we can set. It's probably going to end up being a set. And what we want to then do is say for that specific ID, a change in this case is going to be, I guess we're going to have to get all the keys that have changed. Const. Here, this is what we're going to do. We're going to, why are you not, oh, wrong. I use the same keyboard for both Mac and Windows, so occasionally you will see me accidentally swap my brain to Mac mode, and I don't know, maybe I should use different keyboards to force my brain into one or the other, but I was trying to do what is that, option? I don't even, Command S. That doesn't save on Windows. Numero, thanks, appreciate it. Thanks for stopping by as always. Have a good night. I'm assuming night. It seems like folks are kind of checking out here and going to bed. Perfectly fine. Not saying that's a bad thing, but okay. Change. let's just log it. Console.log change. We're not going to be saving anything, but we'll be able to see that coming through. So that, there we go. So now, oh, we didn't change the signature, so it's still doing to do remove. So here we want to do a to do selection, we'll call it. I must have turned on autosave at some point. I don't remember doing that, but now anytime I make a change, we get the autosave, which is a little bit annoying. Partly just because I'm like not used to it. All right. So, oh, let's log it out here. So we are firing it off. We're getting a selection, right? To do selection, we're passing in the change. Here. Oh, what does this say now? Oh. That would be why. Why are you complaining now? Set to do selection. Oh, can I find import? Okay. All right. Now if we do this, type to do selection. Okay, and then we get this and we get entries. So what does that API look like? Change dot really? Didn't it have like entries and stuff? Change is a selection. Oh, okay. So there's this bit here. If it's all, that says something, but we don't. I mean, we might actually care about if it's all because this might not actually log out. But if we do this, that is technically going to be all. Or maybe it doesn't until okay. So now we have like entries. So we can do what? Entries dot keys. What does keys look like? We just need the IDs. That's the IDs is really what we care about because then we can loop over and do the work that we need to. Set iterator. Okay. Thanks for the sub. I need like, I don't always notice things that come up there unless I'm looking at chat, but I don't always notice the events that come in. Appreciate it. So console.log change.keys. I guess we could just break this. I mean, it feels ugly, but some of this is, I can see why they do it in React Spectrum, but also it becomes inconvenient if you want to do anything else. There. Okay, so we got the keys. But what is with this key? So it is doing an item.id. Item.id, item.content. That is coming from our code here. Oh, and we're doing, it's our bytes to base 64. So that makes sense. So then we should be able to do a, for each of these keys, we can, I mean, we can use the batch API. So we have a todos.set. Set will set a specific state. There's also a merge and a patch. I guess we say patch. It would be nice if we had I should, speaking of to-dos, put this on the to-do list, add a helper text for patch or merge, or because I can never remember what the difference is between them for whatever reason. There's patch, there's merge, and there's set. Set, I think we have to set all of them, so that would be like a complete wipe and erase. Merge would be we would give like additional items, so it's like an upsert. But I think we want to do patch because we only want to change for anything that's changed. We want to say const changes. No, it's not. Changes. Selections equals. Is it going to give us all of them? That's part of the question. I think this is not an actual change. So I'm going to switch this to say selection because I think it is not a, like it's not a diff. I think it's an actual change. Or it's an actual, like, this is the full selected set. So we're going to say selections dot reduce because we need this as an object, which is a little annoying, but as record string, and it is going to be a I guess a partial of a to do. I want to import that, I guess. And because we don't have it imported, schema, yep, type to do. Oh, that's why. I was like, why is it not doing the import thing? We want to also export it. Export down here. Yep, sure. So type to do. Okay, so we have selections. This is what we need. We need to do a reduce. So this will be the final set and item. And we will say return final set. And for each item, we're going to say final set item dot. Well, the item is the ID. So we're going to say this is I don't know if it's going to be set or not. That we're gonna have to check on that. So it'll be ID of item and a what is this? A partial of to do, and a to do's got checked. So checked true. Selection dot reduce. Oh, yeah, because they're using map and set. Oh. I just want the like just give me the I want the array. It's a set of key. So selection is a set of key. Okay, so is there a select? Oh, wait. Dot keys. Is there something else we can do? Like to an array? keys. All right, well, okay. Sure. Item key is not assignable to type string undefined. So this will be a key. So we'll say if no item, and then return final set, I guess. Key is not assignable to type string undefined. I don't. Always such a pain to learn all the syntax. Some of it is like syntax here, at least in this case. Some I'm not disagreeing. Some of it is syntax, but also part of it is TypeScript. TypeScript is nice, but it can be annoying to get it all to work. Kind of, I mean, it feels a bit like in some ways writing Rust, where you put all the effort into getting all the types to work out, and then it works when it actually compiles, which is amazing with Rust. That isn't true with TypeScript, which I think makes it a little bit more painful to know that I'm going to go through all this effort, make the type in my TypeScript nice, and it's not going to have any runtime checks or anything. Like I'm not going to feel confident. Well, I'll feel somewhat more confident, but not entirely so. Okay. I mean, all of it is just because, like, you know, as ID versus string, like, so we're just going to say as string, because I don't think I really care about any of those situations. So now this should give us a record, and we can say patch. Why don't we like this? Cannot read properties of undefined reading invoke. What? Okay, weird. All right. I was like, we didn't change anything around that. Whoops, apparently. Oh, I see what I did. Okay. Sometimes the hot module reloading gets funky. Hello, chat. Now, click. Cannot read properties of undefined reading keys. Okay, so maybe I do need to worry about some more of this bits here. We're gonna do a console.log of selections. Let's see what we're looking at here. Okay, so this is all, I think. Oh. Selection. Oh, you know what? I didn't update this. So change. This is now selection. And if I had looked at there, TypeScript actually would have helped us out. So, you know, console is not a, oh, yeah, all right, well, got part of the way there. The idea was right. The implementation was not. All right, so we got selections. We have ID check true. Okay. So now we should be getting an updated set of to-dos. So we're gonna go ahead and do a console.log here and say to-dos. And let's see if we can check that over time. So we get an array. Content checked true. So checked true is not actually being considered at this moment, which is part of our issue here. So, where is that considered here? Okay, selected keys. Okay, so we're gonna have to like do some futzing right here, which is a little bit annoying, but to-dos.map, it's an expecting an array of to-dos, or an expecting an array of IDs. So we'll say if to-do.checked, then we will do to-do.id. Otherwise, we're going to do an empty array. And then if we do a flat map, that will take this nested array and make it a single level array and give us our state. So now open up this again. So we got some console to look at and say add. Gotta love my test values, right? There we go. Now we don't have an unchecked state. And our clear also doesn't work, but you know, that's something else we can deal with. So the check state works. The unchecked state does not. And we are getting the full list of selections. So we do need to address that. So this selection.keys, it's going to be everything. So I guess in this case, we actually want to do a const to-dos equals yield star select. So that will give us the schema dot to-dos dot select. I guess we do select table as list. That'll give us something to iterate over and import. So you'll see we're starting to like leak into the generators here a little bit. Function star, that's a generator. Yield star, functionally equivalent to async await. So the yield star, kind of like await. You have a little bit more control over what this is doing though, and like shutting it down after the fact, which is nice. But if you squint, this is async, this is await, and that will get you pretty far in understanding what's going on here. So this will give us an array of to-dos, and now we can do this loop-de-loop thing, and we can just check. That'll make it a little bit cleaner because we don't have to do this like selection.keys thing, which is not terribly fun, but it is what it is. So const selected, well, we'll say selections again. We still do need to do the reduce. So we'll do to-dos dot reduce. An item is going to be, okay, so now we're looping through the existing ones. So we're looping through the full set of to-dos. And I guess this is going to be all the to-dos. So we actually do need to attach these to-dos to a specific tab. But future us. Well, we'll get one tab working and then I'll come back to it. I thought of that after the fact because this is like a global store. So now we don't have this like built-in nesting. It was sort of like pre-filtered before almost. Because the state was contained in the actual view layer itself. So now we're looping through all of the to-dos, like literally all of them. And we're saying, in this case, we want to set selection to true. So it will all of them will be checked. I don't care what's being input. So actually, I guess in this case, we can say, we'll say item.id. I guess we'll go the immutable route and we'll say item. And we'll do item. Well, I guess it's not entirely immutable because whatever. True. Okay. And we're going to do a set because we are overwriting like the full thing. Actually, no, let's do a patch because we are eventually going to we only want to patch the ones that actually changed. So this selection will be able to, well, we'll swap that to select only the ones for this specific tab, and then it'll all sort of work. So let's just add a to-do for us. Add or change selection for or to grab only items from this tab. All right. And then what time we got? We're maybe bumping up against when we need to call it a day here. So selections, in this case, we're doing something similar, but not quite the same. So we'll do a to-do dot reduce, to-dos dot reduce. We're going to then do a different check here. Otherwise, this is going to all be the same. And so now in this case, we can operate on the selection. So if the selection is passing in the whole set, we can do has, and we can check on the ID. So this will be a lot cleaner because this is just going to give us the existing state or not, because this selection is going to have everything that is selected, regardless of existing previous state, etc., etc. So now we can go bloop bloop and bloop and blah blah blah. And now if we check bloop bloop, we're not getting anything. Did I actually get those right? My gobbledygook. Cannot assign read-only property checked of object. Why would it be? Oh, because mutation. Yep. Okay. This is the immutable state coming into play here. Perfectly fine. We can do a little bit of this. Inspect, pull this up, now that, and this, and here. Now, there we go. We have changed over all of our selections. Clear doesn't quite work yet, but I'm not going to worry about that right now. Let's add a to-do for that. What is it though? What is it, this comment in there? Oh, no. This. Sure. Whatever. There we go. I want the highlight because I'll show you in a second. To do fix the clear. Will it just let me do this? Yeah, okay. That's what I was trying to do before, but syntax was fighting me a little bit. The reason I wanted to specifically have it as to do is, oh man, I need to clear out all these Rust syntax tree. I don't even know what that is. We've got a to-dos tree. Nice. Now, I can look here and see all the little to-dos that I need to do. Great plugin. Because like that's this slash to do is a seems to be pretty common idiom where folks will just put that in their code. And the fact that I can just like pull it up and have a whole list of it, pretty nice. I mean, you could search for it too, but also like just having it in a spot is kind of nice to deal with. All right, so now we want to do a little bit of cleanup because this can all go away now. Okay. Do I not have Rust or React imported here at all? React, sure. Close, or remove. There we go. Sure. Now we can see that in some, in some ways I like this pattern more because it makes our views cleaner. You are getting global state though, so it's something to think about. I will do some like React set state here and there, depending on the component. Like in some cases, it makes sense to have the component contain specific pieces of state that only that component cares about. This is effectively a global state. Something to keep in mind. But it does all the memoization and all that stuff for you. So it's not like splitting this up. Once you have a little bit of that setup, literally setup.ts in place, spinning up these little helper functions, and then there's the built-in selectors, which we're mostly using here. But we'll also need to this should be using the list ID or the file name and actually we can put that right here. To do only show to-dos for this tab. We can spin up a quick selector for that though too, and it's very similar to the thunks.create. You call it create selector and you write it very similarly. And you can extend them too. So you can have you can write one selector and then you can have another selector use the selector you just wrote. So you can have like derived data off of derived data, which is like for that finance app that we're pulling data from. There's a bunch of graphs. It was annoying trying to keep that state synced. So the fact that I can just write a selector that is just for that or just for that specific graph, or potentially for a couple of graphs that use that format of data, it's really nice. So we get the selectors and the actions, and then that handles a bunch of it for us. What are we doing for time? 2:30. So we've got most of the functionality here. The only bit that I wanted to we gotta persist it still. I wanted to persist still, and then we still need to. I mean, I literally titled the thing WebSockets. I'm going to actually change that because we haven't even touched WebSockets yet, and we're 2.5 hours into the stream. But I guess we wire up the persistor and we'll see where we're at. Give me 1 second. We'll just check the work computer to make sure I don't have anything that I need to deal with. That might make us end sooner than ideal. All right, let's see. Come on, cursor, where are you? There we go. Oh, what am I doing? I've got the trackpad down. What am I doing? Okay. Nothing too pressing. So let's do the file operation stuff real quick. Local persister, we call a create persister. It has a couple bits: the adapter, key, reconciler, allow list, transform. So the adapter is something that we're probably gonna have to write ourselves, which is fine. And the reconciler probably the same. I don't know if do we have to have an allow list? Okay, it says optional. I think we leave that off because I don't really want that. And we're going to wire it up. We're going to remove local persister and we're going to call it Tauri file persister. What theme? Like VS Code theme? It is the I am completely blanking. Sarah Drasner made it. Night Owl. Night Owl. There we go. There we go. Night Owl theme. I am quite enamored with it. Okay, we can pull. Let's see, which key is it? There we go. Store persist create local storage adapter. So we basically just need to do these bits. Bam. We don't need to export, and we're gonna say create Tauri file adapter. We might need to pull in some of these bits, which isn't a problem. Okay, and error. You'll notice that there's a few things. I think these are Starfx things, but they're built in a way that feels very much like using Rust. So okay and error are like the results in Rust, which is I like. Anyways, thanks for stopping by, Channing. Appreciate it. Now I think we basically just pull in our bits here. We get a get, a set, and a remove. The get comes into play for the reconciler. What does the reconciler look like? Store persist. Shallow reconciler, create persister. Okay, so let's pull that over here. We'll take a little peek see at that. I'm gonna move that off because we're gonna be doing a little bit of code here and we don't really care about the state. Try not to kick the cat food. Okay, so persist store middleware. That is still something that we want. I don't see any reason to change that. It's just calling an adapter.setItem. So anytime it changes, we call setItem. Seems fine. If there's an error, catch the error. I mean, I don't. Sure. And then the key is going to be, I think it's just like a string. And state is going to be any state. So I think we can do this as a string. There we go. And then we will call create file adapter here. and that has a get, set, and remove. Why is that complaining? Expected 0 type arguments, got 1. Oh, I guess that makes sense. We get to do a little TypeScript generics. This is going to be a state, I guess. We'll just call it a big S. There we go. So now when we call this, if we pass in, if we implicit or explicit, TypeScript generics. TypeScript generics, if you set something like this, you get the ability to pass in either implicitly or explicitly a type. And that allows you to write a function which takes any number of potential types. So in this case, we are explicitly passing in a state. We're explicitly passing in that type representing our state, and then we are using it in our actual function. So then this function will be generic as we're writing it, but the types that we get returned from this function end up being specific to whatever we're passing in. We have, I think we have all the bits that we actually need. And this is assuming that we're using local storage. So we have a remove and we have a get. In this case, we're doing a, so next state, select state. So in this case, if we have no allow list, it's going to set item with a key and transform state. Otherwise, it'll be the allowed state, and that's based on if we pass in an allow list. So the transform state is going to be our state. So we're saving the big chunk of state as set item key. So we get a key. Where's that key come from? Okay. So if key is this, which actually we should probably change, file, I guess. We'll call it Tauri file. So the key actually doesn't really matter here. We really only care about the set item because we're saving it in some state. What's interesting here is we're potentially saving multiple files. So if we want to persist the state across multiple files, we only need to do it when the specific bit is state has changed. This is just generically like everything. So in this case, we're doing a get item and we're getting it out. This would be like literally every file. And this would be like saving literally every file, which is a little bit so there's a transform. Okay, so this is going to we call this, so persist store middleware. This is going to return a key, an adapter, an allow list, and then a transform. We also have the reconciler. Where does that show up? So create persister. Oh, the create persister is handling some of it for us. So it will do a get item for, this is the rehydrate. This is called when you first load the app. So it will grab and pull that state. And here's our reconciler. So when we pull that state, we set the shallow reconciler as the default. And then that's what pulls it from storage, whatever, however you're storing it. So you might need to make a queue so they don't all try to fire at the same time. Potentially. I mean, we don't have to use this function. This is just a built-in, like, yeah, I'll fire it off and just do all the things. This middleware is going to be called every time a thing happens, right? We only care about one file right now. I think we get that wired up to ship it with just caring about one file, because that's already going to be a little bit complex with the way I have things set up. I only really care about one file. And we had it hard coded before. So I think what we do is we say, we'll add a to-do, update, create custom persist store middleware. And that will allow us to save partial state snapshots to specific files. I'm gonna leave it all in line just so that to-do shows up in my in the thing. Yeah, I'm not terribly keen on that, but it'll be fine for right now. So then what we'll do is we're just going to grab that whole state, because we're not even like, all of our other to-dos are basically saying, hey, we're just grabbing all of the tasks and they're not going to be all applicable here. So it'll be fine because of our other to-dos. Like this, we are literally seeing all the to-dos for all the tabs right now. So it's not clean. I did remove some bits though. Some bits and bobs of, okay, we did clean it up a little bit too soon here. We might have to remake a little bit here, but home. This, we want this, and that will end up going here. And what we're gonna do is we'll do a get item that'll pull it out, and we'll do a set. And I don't think we need to stringify it, but let's pull this in first. I don't actually need that. And I think we do, actually we end up doing a write, and we do a, I don't think we need to open. Actually, no, we could open because we're going to keep the file handle around. We could. Okay, so we're going to get, we'll call create Tauri file adapter. We're going to say const file handle. And this is going to be a, what do we got? This is a export function setup store, create persister. Will give us this. We don't have, we're not doing anything asynchronous right now, which is a little bit annoying, but get item will, I guess it's not going to be convenient to do so this comes back around to, as soon as you make something async, then it bleeds everywhere. If I try to do a file handle here, this is asynchronous, then everything becomes asynchronous. So I'm going to go, we'll call this a file name. And that'll be like the base. And we'll call, we're calling texting code. And in this case, we're just writing out. Yeah, let's just do a open base directory. What else do we got in here? We have a write file, a write text file, and then we have a read text file. And then that way it just auto closes and everything for us, which is going to be kind of nice, honestly. So we can say const file, we'll say const content, I guess, equals yield star this. Now we can, we should, I think this is what we want to do. Yeah, import. So we can wrap a, so right now Starfx is using Refactoring version 3. Refactoring version 4 is in, it might be in beta just now. We're like real close to releasing beta for Refactoring version 4. So this has changed a little bit. But if you wrap a promise and call, you get a little bit of production there. It effectively converts it into an operation, which is the generator equivalent of like a promise in the affection world, that is. So read text file takes a path and then options. And this is where we want to do this. Well, we got this. And then we have this. Well, actually, baster, I guess. And we want to import this. All right. Why aren't you wrapping? Call yield. My parentheses match up. Why are you complaining here? Oh, file name. Got it. Yep. Got it. Need a beat? Like music? So this, I guess we just do this again. I'm not terribly keen on this, but like, we'll go like that. So when you persist it, it's just going to be like a default date. Still, again, not great, but like whatever. Okay, so content. Now we have a JSON.parse, and then that dumps it into the storage. So we're going to need to do something here. But what I'm going to say is storage is this, and we're going to basically no op for the moment. And what we're going to say is we're going to just say a console.log content. So now whenever we rehydrate, we will see that content come through. Key doesn't really matter. And set item. So what we can do then here is what we will do is a persist store middleware. It will take something similar, but this persist store middleware is going to get it's in the next chain, so it's going to get like the current state and the the payload coming in. So we'd be able to see what in the tree is changing, and we'd be able to save a specific file. So we can take just the state for that specific file and save just that file. So coming back around to, do we need to make a queue? Here, this. Yes, but we have one already. Like this middleware is effectively like a queue. We fire off state to it, and it queues up all this state, or it queues up these payloads, and then it processes them. So that payload coming in ends up getting dropped in, it's like part of that queue, and then it gets dropped through all these middlewares. So this persist store middleware would be just part of that middleware stack that gets called. And like generically what it has been used for in, up to this point, Starfx that is, the local storage is just dump all the state to local storage. That we didn't need to be more complex than that. So like this persist store middleware is just, here's some default ones to get you going with local storage, and you can make your own. Because you can use this create persister helper. You can use the persist store middleware helper, but at the end of the day, you're writing another piece of the middleware that gets chucked onto the task stack, and when your payload comes into the queue and gets processed through that middleware stack, it's just going to hit this function, either the one that you're using imported or the custom one you wrote. So you can actually do multiple persisters, which is kind of neat. It gets a little bit more involved with the rehydrate, because you would have to, like, depending on how you're rehydrating, where you're saving and what you're saving, you have to do some logic there, but neat. Yes. and that's part of the reason that I wanted to, that I've been enjoying using this, is the flexibility and just the fact that it eventually just boils down to a middleware stack is really very flexible. So I can get I can use all the helpers, or I can get a real custom with stuff if I want to. Okay, so we've got, we're just gonna log that out. And now every time we call set item, it is going to be saving it. So in this case, we're going to say, we're going to just do file name and const file name equals this, and we'll say to do this will end up being dynamic from the persist store middleware rewrite, from the custom persist store middleware rewrite. But for the time being, we can do a read and then we can do a write. So here we will then end up doing a yield star call write text file. That path is going to be the file name, and our data is going to be a string, I guess. Okay. So we're just going to say, I guess we just stringify it for the moment. I don't really want it like that, but it'll be fine for the moment, until we get pull in timestamps and whatnot and have it in a place where I could copy and paste it into and use it for chapters for the stream. It doesn't really matter what the data looks like. Okay, so I guess we basically just do this, right? We don't care about the key. We're just writing it out. I suppose in theory we could switch that over, and we could use the key for the input for the file name, but whatever, it'll be fine. I don't think we really use the remove. I don't think it's actually used in the persist store middleware. Loud state adapter. So it's just going to be whatever this adapter is. So in this case, the persist store middleware that we're doing is only doing a set item, and then we're calling a rehydrate, which is what this returns. So we're only calling rehydrate, and we're calling set item. So I think this technically doesn't matter right now. So we're just going to say to do handle removal of the file. Good. So now we can get rid of the import there, and we should be able to hopefully see something showing up on our file system here. We're going to open up that folder. I'm doing it on the side because reasons. Okay, so we do need to create it though. So when we that was the one bit that I forgot. We have a, and that's actually where this comes into play nicely. We want to do this file operations. Almost forgot about this little step. That's not a big deal, right? Creating it. That's a little awkward, but whatever. Well, we can update it. We're in the mix. File open. So this will then just create it for us. So if we call open and we call file operations dot options file operation. Oh well, this can be file name. This can just be file ops, and we will unnest this slightly. So file ops, this ends up being a replacement for this. So now open file ops, file name. Okay, what are we complaining about? Type null is not assignable to type promise unknown. So it did an open, and that returns a file. We're calling it call is unknown, operation is unknown. Well, okay. Argument of type window null. What is? Do we get like a weird import here? Oh. Yes, I think is the answer. Okay. It was using open from like the default type. So now, where did my... So when it is calling get item, which should happen in the rehydrate calls select get item. So it calls get item when it rehydrates. Which actually we aren't doing because we turned that off, right? We need to do setup. We need to go to our setup and we need to, it's not the local persister anymore. Oh, actually we were just in this file. We're in setup right now. The Tauri file persister needs to rehydrate. There we go. So now, there we go. We get our text file. If we make any changes to it, it should start showing up in their content. So we get a content file handle. And that's on setup line 82. Okay, so we're calling this. This is actually going to end up being a file. So then it's a file dot. There's a separate read. So if we say const content equals yield star call file dot read. So we open and then we read. Whoa. This seems kind of annoying. Is there something easier than read? Like I just want to. All right. Do we just call read again? We're going for it. We're going for it. This is file. No. Read text file. Does that actually have it built into it? Reads and returns entire contents. Can we do a, if it doesn't exist, create the thing? Because that would be handy. I'm really just like, fine. We'll do it the nice way. So const, I don't know, file dot read. Let's just copy and paste this little dealio here. See, like this. This is all kind of annoying. Number of bytes to read, like all of it. I just want to read all of it. Read incarnate color should always process. So I don't have to push pass anything in, do I? So you have to give it a buffer. All right, is there something better that we can do real quick? Tauri.app, because I just want to get the content there. Plugins and file system, and we were using open. Open was handling some stuff for us. There's different modes. Read, write, append, truncate, which we were looking at. Where is, so create, write, open. Oh, yeah, so if we just want to read, we can do reading text files and binary files. Okay. So can we do a like exists? So that's purely just checking if it exists. Is the well, I guess we can do create. Creates a file and returns a handle to it. Okay, if the file exists, it's truncated. We don't really want that. And then the problem is we also have to close it. Okay, well, let's do an open. So there's read text file, there's read text file lines. I guess maybe we can do a, what else do we have on here? File dot. All right. This is like, it's nice that we can kind of just tuck this away. In this case here, we were opening it. Were we doing anything with it? We weren't like reading, which is part of why we didn't run into this painful bits yet. So this will give us the file info. So if we say const stat equals yield star call. It's a little annoying to do the call, but you know, it's kind of the best way to go. So this will give us a number. So I think we can then do a stat.size. Nope. Argument of type number is not assignable to parameter, so you int array. Mode is GID blocks block size. File attributes number. I'm looking at the types right now because I just need that matching type. Does nothing actually match? Oh my gosh. So file.read takes a buffer of a u int array, which is a length. Okay. Okay. We got this. We got this. Stat dot size gives us a buffer. So we call open. That gives us a file handle. Then we can get the size, and then we get a buffer. Then we can read based off of that buffer and that size. And then we can decode said buffer, and that gives us the content. And we need to also wrap this in a yield. I think technically this still works without wrapping it in the call, but this provides additional safety. I don't actually need that variable, do I? So I gotta call it, and that ends up mutating this. So we're gonna just call that a let, which will technically it doesn't matter because JavaScript's not gonna enforce that, but that is more of just for me, so I know that I'm expecting to mutate that. And then this will give us the decoded text. I'm gonna actually switch that to be content. And now we can log out the content. And hopefully that will create the file for us if it has not yet been created, and read the content. Okay, where is my, there we go. Okay, we got this. Let's do a refresh. We do this. Oh, things aren't working. Stream.add is being called before its thunk has been registered. We are calling setup. We are calling rehydrate. That seems fine. To-do.add is being called. Okay. So if we do this, it's being called before its thunk has been registered. I thought we were registering them. Thunks.bootup. It should automatically register it. All that we changed was this, which is kind of weird. All right, let's turn off the rehydrate real quick. And I just want to make sure that that's the situation that's happening. Yes. Okay, so the rehydrate was doing something, of which Tauri file persister, we're doing persist store middleware, and the adapter, create file adapter. So we are giving it this, and I don't know if that matters, but we need to also call a yield star call file dot close. Okay. Okay, that feels weird that it was an open file handle, but okay. So we should be getting, now if we say hello friends, we should be getting persistence. If we refresh, are we logging out? Oh, maybe that's still broken. I forgot to re-enable it. This. Okay. So why is the persister causing this issue? Well, I'm thinking about it. I'm going to just delete all this because we don't actually need that anymore. Base directory. Oh, file ops. I don't think I actually need that anymore, but yeah. Do I need a reconciler? I might actually need a reconciler. That might be part of it. Well, no. It comes with it, right? Create persister has a reconciler, shallow reconciler. So this, when it pulls in the state, it will original persisted. Okay. We're not actually using it anywhere, so it should just be when get item is called, we should be running it. It is a generator, so we can do a yield call. It's possible that we're hitting an error in here and it's just not being caught, which would be a little annoying, but I'm not going to rule it out. So we're logging out the content. Let's log out the file handle. And just make sure that we're getting into this block here. Yeah, so we're getting the file handle. Stat. I guess we'll say stat and file. Okay, so definitely the file.stat. File.stat. It's a promise. I mean, it could be like, because I've got it open. I'm going to close it. Like, I think we might just be getting weird file handle issues here. File.stat is definitely doing something weird. Because we're getting the file handle. All right, so file dot. We got read, close, resource ID number, seek, stat, truncate, and write. So if we just do purely a console.log, let's just try a yield star file.stat. I think that's just a TypeScript thing that's complaining. I don't think that'll actually matter. Okay. it was throwing, and call was not actually. It's interesting because I would have expected it to like throw. So I think what's potentially happening is we were doing call, it was throwing. So we were getting an uncaught error, and somewhere in the stack, like this adapter isn't actually handing a try catch. So if we did a try, and we did a similar to this, a catch, what now happens? Okay, nothing. So like I'd expect it to be throwing. Either way, we know what the error is now. We need to go into capabilities and permissions, and let's add in the, we don't actually need store anymore. I'm just gonna go ahead and remove that while I'm in here. FS allow open, allow write. And I think we're gonna just do an FS allow stat. Oop, we want this, and this is doing a rebuild. We should get a new version of the app, and then hopefully that works. It appears to be. And if we look here, and we open up this, it is now empty. Where's our this? We want to open up this, and what is our object here? Store. Okay, so that's both of those are the setup. So now if we do, let's just put some gobbledygook in here, and what are we? We're not actually doing any parsing or anything. No, good. So if we refresh, okay, this is still, I think it's still throwing. Console.log yield star file.stat. I'm not sure why I'm future fstat. Allow app read. Wow, this is really small. F stat. Allow f stat. Okay. So that's the issue. I'm not sure why this isn't actually like throwing. That's definitely a here we'll write a to do why isn't this why isn't a thrown error shown anywhere? Because we're doing a try catch and then we're returning an error, so we just might not be handling it higher up in the stack. So it might just be something that we should add in the default setup, or it's a when we write our own custom one, then we just deal with it at that point. So now if we do an add and we get this, we should be able to do this, and then that seems to all be fine. Now if we do something like this, if we go back here, we'll clear and refresh. Content, nothing, which is interesting. Oh, okay. So in this case, we don't need to open it for writing, and we don't want to truncate it. So hello chat. Now when we refresh, I think we're running into this again. All right, what I'm gonna do is here. We're gonna say we're going to log this right here and do a yield star file.stat. Now, hopefully this gives us whatever error message we should be seeing. Okay, that seems to be fine. Now, if we go here, so call seems to be like helping us out here, but it's also, all right, I must be failing in the open. Okay, let's look at our, let's look at the docs real quick. We want to do read true, and I guess we only want to write. By default, the open API only opens existing files. In order, okay. In order for the file to be created, we also have to have write true. So we were wrong about that. So it's trying to create the file, but it can't because we're expecting it, or we only set it to read true. There we go. File handle stat. So we're getting that, and then we'll do a refresh. We're not seeing any content. So is there an error with the read now? Yield star file.read buff. Okay, read not allowed. We have open and we have write. Kind of interesting that allow. Well, we're gonna we'll make that one a read and we'll make this one write. It's kind of weird that write permission doesn't also apply to. You have to do read and write separately. There we go. That's a better way to say it. So this is going to give us allow write, allow read, allow open, and then we have the write text file. Okay. What is this? Payload patches. So now if we do this, yield call file.read buffer. I thought it was working before. Oh, here we go. Hello chat. There we go. There we go. All right. So now every time we refresh, it should persist and pull in from that. Hello chat. Hey. Okay. We got it. We got it. You're looking at CORM. Have you used it much? No, I have not. I have in fact not used it. Don't remember what. I know Chris Piscardi hops on the stream occasionally here. I know. I'm pretty certain Chris has used it, and from what I recall, enjoys it. But I don't know much more than that. There's also what like SQLX. I think I've used one of them. I don't remember, but like the stuff that we're doing with local first and persisting state and whatnot, I'm trying to stay away from databases a little bit because that makes maintenance over time a little bit harder for the like the stuff that I care about. The data doesn't need to be in an actual like database. So I use case just hasn't been there strong enough for me to care. All right, so now we're doing a write text file, which we should have permissions to do. File name, and we're also doing a catch. So like this should be catching for us, TBD on if it is actually. Yeah, it might just be like that call might just be doing it runs it within its own scope and establishes error boundaries. Yeah, so it never hits it then. Wait, probably catches. I don't know. That feels like something is going on with the call that I'm not expecting. So every time we make a change now, it's going to call this, and it'll get the state and do yield. So the length is 0, so it's going to call adapter.setItem. So we're going to get this called every time we make a change to state. So we're going to say console.log state, and we're going to log the state out here. So we should, anytime we make a change to anything, see that being saved. And this is going to be on line 96. Yep. So we got a cache, we got loaders, to-dos. So anytime we do like this, we'll see that come through. Yep. So now the question is, I have a suspicion that, well, we can try that. Let's see if me closing it has something to do with it. Um, 155. No, it's not updating. Why are you not saving? I'm gonna take that off. It will still work, but like, yeah, forbidden path. Oh, yep, that makes sense. State write text file, because we also need to set the base directory. So we need like this effectively, but we don't need write and create. Oh, yep, sure. Call that. There we go. Now, refresh, do the thing, add, go over here, bloop-a-doop, and blip blop. See, now you can see our problem here. One of our two items, all the to-dos are just being shown. It's fine. Don't worry about it. We have to do everything, right? That's why we put it on the list. But it's showing up here. So let's go here. I don't actually, let's see, state. We'll do a JSON.stringify. We'll do a null replacer and 2, so it'll look nice at least. And then the allow list, we are also going to pass that in, and it is going to have streams and to-dos. So now, anytime we reload, we should be, I guess in this case, I can actually just pull in the state again, because right now we're setting storage to this and then we're parsing it. But in this case, we can actually say content or this, because we are writing it out as JSON. So it'll actually work right now. So if we refresh, it's probably an empty document. So we go like this, add some stuff. Now when we refresh, it comes back. And we can look in our state here, and it looks pretty. You can see our IDs, file name. That's our default. I mean, the default we'll have to deal with that. I don't really want to have the default in there. But we got this. So that logic might need to change a little bit because I use the next folder as like my current stream and then move everything else. I move it into a separate folder once it's done. But it's working, it's persisting, and we've got it all like self-contained, which is nice. So now anytime I change state, it's just gonna do it. And I don't have to think about it, which is amazing. It took a little bit of work to wire it up and we had to tweak our permissions. But now, like this just looks a lot cleaner. And even like this can go away. We don't need the file ops, but we have an add and a remove and we're dispatching. And our view feels really clean. Our thunks then self-contain all of the stuff that's like changing the state. And just by the fact that we're changing the state means that it's also persisting and rehydrating when we refresh. So all of that like logic and everything is abstracted into pieces that seem to, at least for me, make sense in my head. What have we got? Almost 4 hours. I'm tempted to pull in the WebSockets. I don't think it's probably not worth it. We should probably just do that another time. There is, let's go to the affection website. We can, you can see what we're looking at here. This is this the old one? Do we even, where's my, okay, we're gonna go like this for 1 second. Where are you, Discord? Yes, okay, I didn't want to, personal information, etc., etc. Okay, go back here now. What's the site? So we've split up the library into kind of a couple pieces here. Contrib, okay. Oh. Is it not published yet? So there's a contrib library, and it has a WebSocket. Here we go. Okay, so if we pull this in, so use WebSocket, returns, and then it has an open event. We could, in theory, just pull this in right away, and that'll give us all the messages. So what we'd end up doing is we have a use WebSocket. It's not an actual like hook, so you don't have to necessarily prescribe to like the React hook idioms. We can basically put this right in, I think, our setup store, and then that means we can. So we have logs. So if logs do this, and then we're going to do this. We're going to say, oh, except it's a yield. That's fine. That's fine. Because what we can do is we can say, so in this case, we're pushing in logs and the tasks. So we're going to say tasks. Oh, here. We'll boot up our thunks. And then we're going to add it in here. We'll say function star. This is going to be our use WebSocket. So now each we would have to pull this in from, okay, that is also exported there. And then we need to pull this in as a dependency. So we set this up once and then we can do some stuff. So for every message that comes in, we're going to log every message out. And this should continue running. And then we can kind of in the same way, like this is effectively every task can end up basically setting up like a listener or a queue or something. And then we just do an operation when we get a response. So we get, every time we get a message, we can push that wherever the heck we want. And we can push it into the, like a state change. So that could become an action or something. So we could have messages from WebSockets. But this also ends up being, there's a bit of a back and forth. So if we put it into a task, we now have messages. So we can send from here, but also how do we do operations on that? So that's going to probably be the little bit more involved bit. Because how are we going to best wire that up? And we'd also have to wire that up to So use WebSocket would give us the connection and messages. We'd be able to log the messages. So what we would want to do is every time we make a change, or every time we save the state, every time we check a box, we want to grab the timestamp. So we would need to have it wired into like our context somehow. That might be the way to go. So within all of our thunks, we have two pieces to it. There's the context and there's next. Thunks.create allows you to define some input, and that shows up in the context under the payload. Context also allows you to do a little bit more with it. We'll take a quick look at what that could look like, and then I think that might be either next week or the following week. Where is that going to be under? Dependent queries, middleware. So here's a good example of like the big middleware stack. So if you're setting up and you're using use API, when I mentioned that it sets up, it like gives you you start out with a middleware stack already. Like this is what it's doing. So it's got this in the stack already after you've used these couple helpers. So you could do the same with the thunk, but it's going to be going to give you a little bit more to it. Okay, so the context object is a plain, and the API is using the context object. So by setting the base URL, that then becomes available on that context. So like this would be the same way if you're doing in any like an Express.js server, and you want to wire up auth. The first step you would do in that middleware stack would be check if that person has authorization. So do the authorization, potentially authentication, depending on context. And then that will return back into that context, that state. Like, is that user logged in? What authorization, what permissions do they have, et cetera, et cetera. Then the rest of that middleware stack, as each function gets called, will have that context available to it. So that's sort of the same thing that they're doing here. So in this case, we have an interface of payload, and then in this thunk, you can define that payload. So there's the name, the payload, and then a hash for the payload. And I think we can change that, but I don't remember how to do that offhand because I've never needed to do that. Yeah, okay, here. Function my middleware. We are copy and pasting these types, which can normally be imported from this. So this is where we can potentially get a little bit fancy because custom context, here we go. So create thunks. So we get a thunk, and then in the thunk we can do like our own middleware function. So this will be called every time we hit that point in the thunk. In the every call of that middleware stack will end up hitting this at one point. So here we do this context.log. It already has the context.wow because it's being set in the previous thunk function in the stack. So if we look at the foundation.ts, we're doing a create thunks. We can add it here. So what's a bit interesting is we want to set up a task which is persistent. So like we want to set up the socket connection and just have it live. So that's the part that I think this is going to be next time. What we look at is or next time as in like the next time we work on this. I think we might do some loro.dev next time. But we do the use WebSocket. This will give us a connection, and then we can listen to any the messages from here. But what we also potentially want to do is use this socket connection and put it on the thunks context. But we want it to persist. I have a feeling it's going to be sort of a mix between the two. And we might need to do like a little bit of closure type work where we do, maybe we do something like this where let socket, and then this becomes this. So now this lives outside of the scope of this, in which case we can then say, well, we've got this thunks.boot up. We could actually, we can get a little fancy where we're exporting thunks. Let's actually make this in a big function that we call. It could work. It'll take a little bit of futzing around though. So I think that's definitely going to be a next time thing. We have the trappings to handle it all though, which is kind of neat. So we're just going to do this for right now, and a to do wire up WebSockets. All right. I think that's where we're at today. And you can see again, our state is still persisting and everything. We're getting all loaded in. And like as the days go on, this date thing will change, which is going to be kind of goofy until we do some of these to do, but it works. We've got everything encapsulated where, but it's all encapsulated nicely is what it feels like. And if we need to look at the file operations, this is all in the persister. If we need to look at the view, we just see the data coming in that's well typed. And if we need to do any actions, they're in the store.thunks. So I'm liking this setup much better than what we had before. And we could potentially take in some of these bits like the notifications and shortcuts and tray and pull those into that middleware stack. So we can have those operations where like that context, we could potentially make that context have other functionality. So like we wire up and do the notifications that's coming in as a context, we'd have this send. So if that's just available in the context and we can call it from anywhere, it would end up feeling pretty nice because all of our actions can do whatever work it needs to, and they can fire off these side effects as it needs to as well. So next time, almost 4 hours. It feels a lot better. This was definitely a set the foundation, and we didn't get in WebSockets, but it is what it is. We got some things done, and it feels like some solid progress at least. We'll pick it up either next week or the week after. I'll schedule the stream. I did want to get into Laurel.dev. I think that could be next week. I'll sit on it. We'll get something scheduled on the calendar for next week though. So have a great rest of your week, everybody. Happy Tuesday. Keep on shipping stuff. Bye.